My name is Domonkos, and I've been dealing with radio security for the last 7 or 8 years of my life, and I turned my attention to GSM around 2 years ago. I presented at last Hacktivity 2 about eavesdropping GSM with cheap RTL SDR dongles, and now I turned my attention to the other side of GSM, which is the network side, and I wanted to share with you a little finding I had while I did that. So today's agenda is a little bit of history about GSM denial of service attacks, what is possible, what's needed, and what we can do today, what we know of today. Then talk a little bit about location updates and location area codes, what that is, and how that relates to the attack. And finally, there's going to be the attack, hopefully with a live demonstration. We will see how that goes. So, history of GSM denial of service attacks. Of course, as in case of every single radio-based technology, jamming is always there, which means that you are continuously transmitting some noise on the same frequency, and then that blocks every normal communication, every way of communication for the users. I put it in parentheses because I think that that is not GSM specific. What I really like to more talk about is the other three of them, which are based on the GSM standard, and they are more advanced attacks, I would say. So the first one was presented in 2009 by a gentleman called Dieter Spar, and it's called Rachel, and RACH means request for access channel, and this is used by handsets to send such requests when they want to talk to the base station. So the main idea in GSM is that the base station talks usually to the phones, but when the phone wants to do something, then it needs to send a request for a channel. And the base station has limited amount of channels for mobile handsets. And what happened here is that Dieter just kept sending these requests to the base station, and eventually the base station ran out of available channels. So other users who wanted to connect to the base station and get a channel to do some transactions, they were not able to do that because the base station had no free channels left. So as you can see, this attack affects one base station, but every single user that would like to use that base station. And then in 2010, there came Sylvain Munoz, and he showed us IMSI detach attack, which IMSI detach is a message that your phone sends when you turn it off. So to help with the user experience and to help dividing network resources, the network wants to know when you turn off your phone, so it will not keep looking for it when someone tries to reach you. So it's a standard thing. Not all the phones do it, and for example, if you pull the battery out of your phone, then it will not send this message, of course, but when you use the proper shutdown method, then it will send in an IMSI detach message, and that will turn a bit off in the database of the network, and this bit will indicate that the phone is turned off, so don't keep looking for it. And it's unauthenticated, and you can just use the target's IMSI as the sender IMSI, and then the network will think that the phone is turned off, and it will not even try to reach it, meaning that the victim will not be able to receive any calls or text messages. And the third one was introduced by Nico Golde in 2012, and it's a paging race condition. And what this means is that in GSM, when there is any action going on, what happens is that the network pages the phone, which means that it sends out a question. It's really similar to the ARP messages in networking. It sends out a message saying, is there a phone with this and this ID? And then the phone answers, and then they start the communication. And what happened here is that Nico created a special firmware for these open source mobile phones, these Osmocom phones, and that phone was able to answer the paging faster than the regular phone, the official target of the paging. And that meant that Nico could answer the paging, and then the network will try to contact him, and then he will just drop the connection, meaning that the network will try to reach a phone, Nico will answer it, and then the connection will be dropped. So this could be used as a targeted attack on one IMSI, or one phone number, as we would say, and And this could be used to terminate calls before them getting to the target. So, and today's attack, what's the difference? This attack combines two of the attacks I covered, which means this is target head, which means from a single phone number, you can attack a single phone number, or you can attack all the phones, or you can attack multiple phones, because we are using an IMSI as an ID of the phone, and then IMSI could be easily determined from the phone number using online services. And of course, if we are not specifying any IMSI filters, then we will accept all the IMSIs trying to connect to our network, and then we will make them fail, but we will talk about it later. And it's not necessarily instantaneous, which means that you can carry out this attack, walk away, and it could happen like a minute later, or it could happen, actually not a minute later, but it could happen in a specific location. Meaning that I can send a message to your phone, well, we'll talk about it, right now, and then I can make that message so that when you walk home, you will not have coverage at home. You will have coverage everywhere else, but you will not have coverage in a certain location. And it won't be easy to figure out if it was me or someone else or what happened exactly. So that's an advantage from an attacker's point of view. Okay, getting to location areas. In GSM, there are cells and there are groups of cells, and the groups are called location areas. As the name suggests, they are based in the same location, and usually like 5 or 6 or 7 cells are combined into one location area, and each location area has a code. So as you can see here on the picture, we have 3 different location areas with different colors, and each has some cells in it. So what happens when the phone enters a location area? It needs to send the location update, so the network needs to know in which location area the phone is residing, meaning that the phone needs to report this to the network. And the 3 cases when it happens, and when you turn on your phone, if you turn on your phone, of course it needs to tell the network, okay, I'm here, I connected to you, and I'm in this location area. Or when you just walk and then you hand over to a different cell tower, which is in a different location area, you will need to send a location update saying that I moved to this different location area. And there is also a way to command the phone, this is from the network side, to do regular location update, which means that even if the phone didn't move at all, you need to do a location update like every 30 seconds or every some minutes, whichever the network operator decides to set. So, and of course, if there is a location update request coming from the phone, the base station can reject this for various reasons. And this is just a standard procedure saying that I will not allow you to update your location through this base station. And there are many causes. I just listed some of here, like cause number 13, which means roaming not allowed in this location area, which means that the phone will not try to connect to any cell towers in that specific location area. Or if there is cause number 2, this means the IMSI is unknown in the HLR, so there is something wrong with your IMSI because it's not registered to the database of the operator. Cause number 3, illegal mobile station, which means there is some problem with your SIM card. Or, for example, cause number 6, this means your phone is blacklisted, it's stolen, so it's not allowed to do anything. So how does the phone react to these different causes? If we set the reject value to 11, 12, 13, or 15, then this is actually a quote from a base station's manual telling the operators like what's going to happen if you set this value to this. And it says that the mobile station will set the update state to roaming not allowed, meaning, as I said, that the phone will not be able to have coverage in that area because it will not be capable of connecting to a location area, to cells in that specific location area. If we change the reject value to 2 or 3 or 6, then of course the mobile station will set the location area again onto this roaming not allowed list, meaning that it's not allowed to connect to it. But then it will consider the SIM card as invalid until the phone is switched off or the SIM is removed. So meaning that if one phone receives such a message, it will stop connecting to the network and it will not have coverage until you restart it or you remove the SIM and put it back again. And there are other reject values, of course, because of, like, let's say number 4 is not listed here, or something like above 16 or something like that. These are considered as abnormals. I'm not sure, I haven't tried it yet, but it would be interesting to see how phones react to that. And as I already kind of spoiled it, what we're gonna do is we're gonna set up a fake base station, and then we will get phones to connect to it. And then in the end, when phones try to make a location update, we will reject the location update with a specific cause. And how do we do that? Well, first we need to have a fake base station. For a number of years already, we have an open implementation of a whole mobile network from the customer database till the base station radio interface. It's all open source. You can use it freely to whatever reasons you want. The 3 components are OpenBSC, OpenBTS, and Osmo TRX. What they do is OpenBSC is the network side, meaning that it contains the customer database and it contains information about the network. Osmo BTS is a software which connects to Osmo TRX, and what happens here is Osmo TRX is an interface to radio stuff like software-defined radios or an Osmocom BB phone. So Osmo TRX will connect to the radio, let's say to the antenna, and then Osmo BTS will take the packets Osmo TRX receives and will put it through a standardized network-based gateway to connect with the BSC, with OpenBSC. I know it's kind of a complicated, but these 3 systems work really cool together, and you don't need to configure them much. It's already, the default configuration works all the time, so it's really easy to do that. And so you need hardware, of course. You can use a software-defined radio hardware like a USRP, or there are other software-defined radio products which could be used to create a base station. And there is also support for using an Osmocom BB phone, so such a little Motorola phone which has an open source baseband running on it. It could be used to create a base station. And it is really limited because of the phone's limited resources, but for our purposes it works quite well. So it's a good match for this attack. So the next question is, now we have a fake base station set up, how do we get the phones to come to our base station? Well, one would think that the only reason why a phone would hand over to a different base station is the signal quality, or RSSI, which means that we tune to the right frequency and then we hope that our signal will be stronger than the signal of the official network. Well, it's not 100% the case, because for some reason, probably for law enforcement reasons, GSM has built in special algorithms called C1 and C2. And these are the algorithms which has an output which will change the way how the cell selection and the cell reselection, so the handover procedures happen. What that means in reality? In reality, this means that if the C2 algorithm comes up with a really high value, then the phone will prefer that base station and will try to connect to it. And how does the C2 algorithm works? It's just a simple equation. I didn't put it up here, but it's not that complicated. But the main factor in the equation is the so-called cell reselection offset, which is a value broadcasted by the network. Meaning that if we set the cell reselection offset to a really high value, that will actually bring up the C2 value of our BTS to a really high value, meaning that we will be the best tower in the room, no matter how bad our signal is. And to put this in like a real-life scenario, I had one tryout when we had an official base station of one of the Hungarian operators' network running, and it had like a -20, -30 RSSI, which is really, really good quality. And I set up my fake base station, and it had like -60 or -70. But because of the C2 value, actually phones started handing over to it because they thought that my base station is a lot better. Why is this so set up? For law enforcement purposes, we think so, because police really likes to use IMSI catchers to gather information about people in a certain location, and you need to get people to actually connect to your network to grab their IMSIs. and that's why this value has been introduced, probably. We haven't really thought about any legitimate reason, like why would you base the reselection on something like that arbitrary transmitted. So as I said, we need to set this reselection offset really high. What we did is set it to the maximum, of course, which is 126, and then we waited. And it was funny because we had many phones in the testing lab, and iPhones handovered immediately, but like other phones, like my older BlackBerry, which I used to monitor the network, it has a nice engineering mode in it, it just didn't do it. So I started looking at the values, and it turned out that BlackBerry uses, and older phones use, short integers to store this value, meaning that I set it so high that actually there was an overflow in the value, meaning that I saw that C2 value was like minus 100. And, well, that's not high enough for the phone, so I needed to tweak the value. So I figured out that like around 40 or 50 is great, and it's already a lot more than what official networks broadcasting, so phones will just hand over fine. And as you see, actually, we just built now an IMSI catcher. We have a fake base station which lures phones, and all the phones will connect to it. Okay, now one more thing left is we need the phone to initiate a location update request so we can actually reject it. It's easy because we will set our base station's location area code to something different than the location area code of the towers around us, and then the phone will think that it moved to a different location area, so it needs to do a location update, and then we will reject that. So now, again, the attack summarized. We will use an Osmocom BB phone as a base station, and we can do many things. We can make phones disable themselves in specific areas, as I mentioned in the beginning, meaning that, let's say I will create a fake base station with the location area code of the cell towers around your home, and then I will have your phone coming to me, I will reject it. The phone will just store this location area code in the SIM card, saying that I should not connect to any cell towers in that specific location area. So when you get home, suddenly you will not have coverage at all. Funny thing. Second one is disabling the phones around us, meaning that I will just broadcast a value like code number 2 or 3, saying that the phone has been stolen or you have a problem with your SIM card, and your phone will just stop working. And there is also a way to do permanent damage, at least in theory. I heard of a case when the phone received code number 6, which means the phone is stolen. The phone disabled the GSM radio in it completely, and there was no way to re-enable it again. I haven't tried this code number 6 yet. I'm not planning to do it today, so you will be safe. But it would be funny to see such a phone reaction. And okay, so now we're going to do the demo. I've been working a lot on this demo lately, and I really hope that it's not going to crash. I had some problems with it, but I'm really sure that it works fine. It's not harmless, of course. Your phones will have no coverage when you are on 2G or so GSM. So if you don't want to be affected by this attack, turn your phones to 3G mode. If you want to get affected with the attack, you can fix this by simply rebooting the phone after that, or turning airplane mode on and off. That worked on some phones too. Then do that. Yes, I think that's all what I wanted to say. I'm gonna do just one Hungarian operator here, probably Telenor. How many people use this Telenor here in the room? Okay, quite a few. That's good. Okay. So how many of you would like to participate in the demo and stay on 2G or turn on 2G? Okay, 1, 2, 3. Okay, that's nice. Nice feedback from you. Okay, let's get to it. So what do we have in here? I just opened up the configuration file of OpenBSC, which is the network configuration file. And the first thing I need to do is change the accept policy from accept all to closed. This will cause the OpenBSC to reject every phone that tries to connect to it. And then I will change the reject cause from number 13 to, sorry, number 2. He said 6. What an evil guy. No, it's going to say number 2, meaning your SIM card is invalid. So SIM card popping off, putting it back will fix it, or rebooting the phone. Okay, I will save this file. And now I will try my tool. It's called lured, which means location update reject denial of service. I really suck with names, so don't judge that. And the first thing we will have is, I have two Osmocom BB phones here. I start the first one, and the first one is just going to be like a network monitor. It's going to scan for all the networks around us, and it'll put us up a nice list of the networks. After that, I will select the network I'm going to target, and then it will change the values in the config file we saw to use the right frequency, then to use the right mobile country code and mobile network code. These codes are used to identify operators. So maybe you can see on the screen MCC 216, that's the code for Hungary, and you will not see anything here because this frequency range is not being used by any Hungarian operators. And then there is MNC, which is which identifies the mobile operator or the mobile carrier in the specific country. And as you can see, it tries to sync to some of it and get some information. And okay, so it found all the three carriers, Telenor, Vodafone, and T-Mobile. I'm going to go for Telenor, as I said, and then let's hit it. So what happens now, I didn't say that in the beginning, but what happens now is that we need to broadcast on a channel. Wait, just let me start and then I will explain. Oh wait, I need to press enter and start my second phone. Here we go. So the phones are not monitoring all the frequencies available. They just monitor the frequencies that are the neighbor cells of the base station they are connected to. Meaning that we need to select one of the weakest neighbor cells around us and then tune to that frequency. So it means that since the neighbor cell is really weak, we will be able to override it with our base station, and the phones will keep looking for it since they know that there should be something on it. So I will just go to my BlackBerry and see how things are going here. Let's have a look. It shows me that currently I don't see anything, which is not that good, but everything looks fine so far. So I will just wait some more seconds for it to recognize. Okay, here it is. It shows me that on frequency 41 there is a tower, and it connected to it, and we will see a reject soon. And there is a location updating reject. It went up really fast. But right now, on my phone, I don't have coverage at all. It just went away. Okay, he's searching. On iPhones, I'm not sure, because in recent iPhone iOS versions, you will not be able to turn off 3G, but maybe you are able to do that. Other people using Telenor, I don't see anything here yet, so maybe you are not affected yet. Maybe this thing is just shielding. I will just put it out in here. Maybe that helps.
I got an emergency service blog message.
Okay, that's good. I mean, of course, I'm a responsible guy, meaning that my base station advertises itself as a base station that's not capable of. Yes. No, well, he asked if it could be used to do emergency calls. What happens here is my base station has the bit flipped, saying that it could not be used for emergency calls, but actually your phone could use the regular towers to do emergency calls. So if I try to call 112, it's gonna ring probably. Oh wait, it's not. Nice. I didn't thought. Oh yeah, it doesn't work. Fine. Then no, I'm sorry. I thought it shows in the top it could only be used for SOS, but no, it could not. Okay. Quick show of hands. Anyone else except me being affected by this now? So your phone dropped coverage, like anyone really in the room. Okay, there is 1, 2, 3, 4. Okay, that's quite good. I will just try to put it here like that. It's really safe like that. Okay, I will just have it running here, and then yeah, I will just switch back, and then thank you for your participation, of course. And it works really well, trust me. I mean, the range of this phone is not that much, but as you can see, like around the 5-meter radius, something like that, it could be used. So, and you can put this whole setup in your backpack, walk around it, and then have people like dropping coverage around you, which is, I think, nice. It looks like in action movies when they explode things, but it's just coverage dropping around us. Oh, and one more thing that many people ask me, when you are actually in a call, this does not work because when you are in a call, the network coordinates your handovers, not the phone, because the network needs to know where you're going to hand over to keep the call alive while you do the handover. So if you are in a call, then you will not be affected. But as soon as you hit the end button and you return to idle mode, which is called when you are not in a call or not receiving anything, then it will be affected. Are there any countermeasures? Well, the whole concept in GSM is wrong. Because the GSM standard's main idea is the tower is trusted no matter what. So who would create a fake base station? Like when they created the GSM standard in 1990, like who would think about something like that? It's not possible or nobody's going to do it, it's expensive. Well, after 24 years, we are here and everybody can create a base station at home. And you can use 3G or 4G, as I said. If there is jamming possibility, of course, so there is actually quite cheap jammers available which could be used to just make you drop 3G, 4G and make you drop back to GSM, and then you will be affected. So until there is no way to use 3G only and not fall back to GSM, you will be affected by all the GSM attacks available today. So I have some ideas like what this could be used for. You say, okay, phones could use 3G easily today, and I'm not affected by this at all. But how about other GSM-based systems, like house alarm systems that report back to the center via GSM, smart meters, traffic lights. I've seen traffic lights using GPRS easily. Also, like a railway GSM, which they use to carry signaling information, something like that, through GSM. These are all affected by this. And the question is, like, how often do you reboot your home alarm system? I mean, not that much, I guess. So if there would be a really technically advanced burglar trying to rob your house, he could just cut the wire to the PSTN, so to the public switch telephone network, and in the same second just turn off GSM, and then, well, nobody's going to notice it, for example. So my conclusion is that, and I heard this from also some other people, that GSM will probably survive 3G and maybe even 4G because it is used by so many legacy systems and so many embedded systems that, and it has now pretty much 100% coverage, meaning that it's everywhere, so it's the ultimate fallback. And I think because of that, this is still a good area to do research on, and especially with the great tools we have. So if talking about tools, I would like to give a huge applause and a thank you for all the tools and all the creators of the tools especially. So the Osmocom project, of course, is a great project with all the components being used is listed here. So mainly everything that I use except for my little script that put it together is just there. It's from the Osmocom project. And the people here on the bottom, they contributed a huge amount of work to make this possible and make other GSM-related researches possible. So I really thank them for doing that. And with time, okay, I just spent like 32 minutes, so we have a lot of time, but I've been already asked to go to the speaker's corner and answer questions there, but since we have so much time, I think I can take some questions now, if anyone has any. Yes? So the question was, I guess you want to create a fake base station, but for 3G? Yeah. Yes and no. So to elaborate on that, what happens is that, like, 2 months ago, there was a new project announced, which is OpenBTS UMTS, and this is the first known 3G open source implementation we know about. It has not been tested by many because the code has not been published, but they promised that the code is going to be published. It's really limited right now, and it requires a really expensive and huge software-defined radio. but many people say that once the code will be released, so there will be an open source implementation of 3G, then adapting it to other software-defined radios would be easier. But it will take some, like 1 or 2 years, I guess, maximum, I'm not sure. But so there is a project, it's limited, it's not there yet, but it's a start. So we might see something like that. But in theory, to go back to like creating a fake base station, not just a simple base station, 3G authenticates the tower too. So there is mutual authentication instead of just one-way authentication. And because of that, if the phone which you're using does not have your SIM card in it, meaning that you know the key from your SIM card, then you won't be able to create a base station that the phone will accept as a legitimate base station.
Maybe you can try man in the middle.
Man in the middle, in what way?
Authenticating to the network with your BTS receiver
Okay.
mode and with the client mode, and another base station publishing the network to the attack phone.
So you would be relaying the signals. Yes, but the problem with that is that all the signaling messages are signed. Meaning that you cannot, like you can relay it, of course, but you cannot change anything in it because the phone will detect it. So you cannot like do funky stuff, meaning causing a reject being sent or something like that. So yeah, you can relay, but then it would be like a 3G signal booster kind of thing because you can just blindly relay all the frames received from the network. Yeah.
So I can capture the crypto.
You can capture the crypto, but there is no known cracking method right now. You can try brute forcing, but as far as I know, the keys are quite long in 3G.
What happens if I disable encryption?
You cannot do that. You cannot disable encryption on 3G because the message for that would be authenticated and signed by the network. And also, I don't think 3G even has a mode of not having authentication, encryption turned on. It's safer as we see right now, but who knows, like, we will see. LTE, I did not do much research on LTE, actually not on 3G either, but as far as I know from security-wise, it's at least as good as 3G or even more advanced. I know it's a much simpler architecture, and it uses a lot more it uses more of internet and IP connectivity kind of stuff, but as far as I know, it's quite good. Right now, of course. Okay, with that, I will thank you for your attention.